All right, it's 10 o'clock, so we're going to go ahead and get started. Welcome, everybody, to this week's episode of the Long Coffee Break. My name is Jason Long. I'm a sales engineer here. Really appreciate everybody's time. Thank you for joining us. Today, we get to talk about data center cooling with Stulz, one of our partners, and their broad range of innovative solutions. We're joined by Dave Meadows. Dave is the Director of Technology for Stulz. He's been with the company for over 20 years, so he's an incredible resource for our team. He is a member of all of the key national data center committees, including ASHRAE TC 9.9 and 90.4. So Dave just has incredible experience, and we're really lucky to be joined by him today. Thank you, Dave, for being with us. And with that, I'm going to turn it over to you.
Great. Thank you very much, Jason. And thanks to everybody for joining us this morning. Just real quick, to get this out of the way, I would like to talk a little bit about the Stulz organization. Stulz is a global provider of data center, computer room, and telecom space cooling technology. We have 11 production plants throughout the world with 21 subsidiaries, and we have a direct presence in over 130 countries. Stulz North America offers 312,000 square feet of manufacturing facility in the United States. That's split between our North American headquarters in Frederick, Maryland, which is sort of sandwiched between Washington, D.C. and Baltimore, Maryland. Here in North America, we design and build all our equipment for the North American market. And because of this, and because of our ability to source American vendor parts, we can meet all the requirements of the Buy America Act of 1933. With that out of the way, I didn't want to spend a lot of time today talking about traditional CRACs and CRAHs, but I thought this would be a good place to start. CRACs, also known as computer room air conditioners, are DX units designed for the white space or the data center. And CRAHs are computer room air handlers, which are chill water units designed for that same space. We have a very diverse offering of products. If you take a look at the slide here, it pretty much covers the gamut from our smallest units that run around about 2 tons per unit to our largest CRAH units, which currently are about 300 tons per unit of high sensible cooling. So the real purpose today, and what Jason asked me to speak on, was some of the non-traditional data center, computer room, and telecom space units that Stulz currently provides to the North American market. I want to start out with our modular cooling solutions. These are chill water units, computer room air handlers. The Cyberair 540 is currently designed to provide about 45,000 CFM. And at ASHRAE Class 2 return air conditions, providing about 500 kW of cooling per unit. So that equates to roughly about 145 tons of cooling. And then its big brother is the Cyberair 1080. This is a massive unit. It's moving 96,000 CFM against 0.2 inches of external static pressure, doing over a megawatt of cooling, so somewhere around 307 tons at ASHRAE Class 2 return air conditions. It is currently the largest computer room air handler on the market. I definitely want to spend some time talking about the Cyberpack product, because I think this is a product that we see a growing demand for many reasons. So what the Cyberpack is a true rooftop CRAC unit. And that means that it's designed for some very specific things: tight controls, high sensible heat loads, very high return air temperatures. There are some great advantages to this type of CRAC. What it does is it moves the cooling infrastructure away from the white space. So that white space can be maximized for revenue generation, as opposed to being the location for the cooling equipment for the data center. The Cyberpack units are designed specifically to operate in both cold and hot ambient environments. If you look at our range there, we're able to operate from minus 30 degrees Fahrenheit up to 115 degrees Fahrenheit with no loss of capacity. We are able to achieve that minus 30 head pressure control utilizing a standard flooded head pressure control system. In other words, at very, very cold temperatures, we backflood the condenser coil with liquid refrigerant to limit its effectiveness. We also have electronically commutated fans, which are extremely energy efficient and are very, lend themselves nicely to very precise control of the airflow rate. These are located on both the condenser sections for air-cooled units and also in the supply air section of the unit as well. The Cyberpack units are available with 100% direct air economization. Everything is provided for the air side economizer with the exception of the exhaust or relief vent. We will control it, but that has to be installed in the building somewhere. The great benefit of the direct air economizer is that anytime that the conditions outside are not too hot, too cold, too dry, or too wet, we can turn off all compressors and utilize the outside air to cool the data center. One of the other things that sets a rooftop crack apart from its comfort cooling brothers is that it has a high SCOP. That stands for sensible coefficient of performance. This is the metric that would be the equivalent of EER in a comfort cooling piece of HVAC equipment. The only major difference between SCOP and EER is that the SCOP uses like units as opposed to different units that you have in the EER. And also we get no credit for any latent cooling that the piece of equipment does. And the reason for this is typically we do not want to strip moisture out of the airstream in a ITE or information technology equipment environment. And the reason for that is that very low dew points, we see an increase in electrostatic discharge failures of the servers, switchgear, etc. We also offer these units with tandem compressors. What this does, these are two circuited systems. So one circuit would have two smaller compressors. The other circuit would have one full-size compressor. Coupled with the advanced controls of the Cyberpack, this gives us truly 4 distinct cooling capacities within that piece of equipment. The next thing I'd like to talk about is indirect free cooling or economization. Now, the free cooling units are designed specifically to provide for compressor-free cooling during those months of the year where it is cold enough outside to cool the glycol solution that is used for the condenser, such that it can provide the cooling to the data center. So there's 2 coils in there, and what you're seeing is a cutaway of a upflow free cooling unit. So the air would be coming from the white space, the data center or computer room, coming through the front of the unit, hitting that free cooling coil first. And if it's cold enough outside, we would direct the glycol solution, the cold glycol solution, through that coil to begin removing heat from the space. Should the glycol not be cold enough to remove 100% of the heat load, then we can bring on the DX coil to provide cooling. And it's very important because with today's requirements for data centers, we'll see that utilizing a system like this leads to easy compliance with the International Energy Conservation Code, ASHRAE 90.1, the energy efficiency standard for buildings other than low-rise residential, and the new ASHRAE 90.4, which is the energy efficiency standard for data centers. The way the free cooling units work is that during warm weather months, the unit acts as a traditional crack unit. So we're operating the compressors as necessary to remove the heat load from the space. It's important to note that in the majority of crack units, the energy usage that's required to provide the cooling, 75% of that energy is going into the compressors. So anytime we can turn off one or all the compressors and provide cooling, we have the potential to save a tremendous amount of energy. With no compressors running, we're saving approximately 75% of the energy and therefore the money associated with that energy, and still providing the cooling. So in the in-between months, these are months where we have some cool hours during the day, or maybe during the night, it's much colder because these facilities are typically running 24/7 at full load. We can actually turn off one of the compressors, so we can save a significant amount of energy. And then in the cold weather months, which in certain locations such as Colorado, there's plenty of opportunities and hours per year to operate as a compressor-free glycol-cooled, basically think of it as almost a chilled water unit now. So we have the ability to provide 100% of the cooling with very precise control at just a fraction of the energy usage that's typically required to move that heat. Very quickly, I'd like to talk about IDEC designs. This is the indirect evaporative cooling. These are units that are designed specifically for data centers. Once again, we are trying to remove the cooling without the energy cost of running the compressors. In the IDEC unit, we have an air-to-air heat exchanger. So we have the cold outside air passing through the tubes of the coil, and across them we are flowing the process air that's going back to the data center. And during the cold months, we're able to operate this purely in a dry mode. In other words, the air outside is cold enough that that air-to-air heat exchanger is able to remove 100% of the heat load. Now, as the dry bulb temperature increases, say in the spring, now what we can do is we can start controlling the application of liquid to the outside, water to the outside of the air-to-air heat exchanger, and take advantage of the latent heat of vaporization. So we're able to use evaporative cooling to lower the temperature of the supply air at a very low energy input. Now, as the wet bulb temperature increases, we begin to lose the efficiency of the evaporative cooling, at which point we would bring on a backup DX circuit to provide primarily a trim cooling effect. In other words, we don't have to remove the entire heat load with the compressors. We just have to knock it down that last couple of degrees to get back to set point. In the data center world today, custom indoor air handling units are very prevalent. Stulz has many different models to offer, from standard to custom to semi-custom to complete ground-up designs. The staged fan coil designs are typically designed into the architecture of the building. We also provide custom indoor AHUs with chill water and direct adiabatic cooling options. Now, the direct adiabatic cooling options allows for an extremely efficient cooling. It does have the downside, though, is you do not have control of the moisture content in the space. If we're using a direct adiabatic solution, whatever the cooling requirement is, that's what the moisture content is going to rise to. These are typically found in larger facilities where people are not quite as concerned about things like advanced corrosions on the server boards and things of that nature. This is our micro data center. Think of it basically as a data center in a box in a very small footprint. Everything that you would expect to find within the data center, you will find within the micro data center, such as the cooling, the power distribution units, the uninterruptible power supplies, fire suppression, closed circuit TV, security, etc. So in these boxes, you can put them in places that are not quite as, say, pristine as a traditional data center. You can put it on a production floor, for example, to control CMC manufacturing processes. And the standard models basically are designed up to 25 kW of air cooling. Now, we do have some cutting edge technology that we can apply for much higher loads, up to 80 kW. And this technology is our direct liquid to chip systems. Many of the server manufacturers are making liquid cooled servers these days, and we can provide up to 80 kW of cooling in that module. Typically, you would only see these really high watt density applications in high performance computing labs, such as a university, or maybe a cryptocurrency mining operation. Touch real quick on our ultrasonic humidification product. This is very popular in data centers and computer rooms because of the very precise control provided by the ultrasonic humidification. And not only that, because it is an adiabatic humidification process, we are able to provide some additional cooling to take some of the cooling off the HVAC equipment. These units are only using about 7% of the energy of say an infrared humidifier, and less than 40% of what you would expect in a steam canister humidifier. Getting close to the end here, all Stulz units are controlled by our E² controller. This is a PLC controller, a programmable logic controller, that is able to communicate to BMS systems through Modbus, BACnet, HTTP, and SNMP protocols. We also offer within the platform a PLAN option, a private local area network, where in the absence of a BMS system, you can link up to 8 units together on the PLAN. What this does is it allows you to utilize a lot of the benefits of the building management system without the cost. So you can do such things as capacity assist, equalize runtimes among units, operate N+1 units as required. One of the great advantages to this particular control platform is that we have the ability to customize our software, so we can write our own software for any specific needs. With that, I'm going to touch on my last subject, which is testing and validation. In the mission critical environment, it's very important that when we tell somebody that they are going to be able to achieve a certain capacity out of that piece of equipment or a certain airflow, that we are able to provide it. We recently completed our new test laboratory. It is one of the largest test laboratories in the United States. We're able to test units up to 1.1 megawatt of cooling, so well over 300 tons and up to 96,000 CFM. One of the great advantages to having this test laboratory for us is that we can take the test data and then apply it to our models that we use to determine performance of the HVAC equipment. And it basically allows us to fine tune those models to ensure that what we're telling our customers they're going to get, they actually get. And with that, I'd like to thank you all very much for your time this morning. I'd like to thank Jason and the folks at Long Building Technologies for inviting me today. And if anybody has any questions, I'd be more than happy to answer them if I can.
Well, thank you again, Dave. And thank you everybody for joining us. We really appreciate your time. Next week's topic will be reducing spending with channel blending. We'll have Travis Starnes from Blender Products with us, along with Bill Rohn from Long Building Technologies. Thank you again to everyone. Have a great week. We'll see you next Thursday.